everyone, this is Rupal Gupta. Welcome to the mathematics classes. Today we will learn how to solve the algebraic equations having variable on both sides. And after that we will solve question number 1 to question number 5 of exercise 2.3 from chapter 2 linear equations in one variable. In the beginning of this chapter 2, linear equations in one variable, we have already learned that an algebraic equation is an equality involving variables. It has an equality sign. We have already covered this part in a very detailed manner. Kindly do watch our previous video. Moreover, earlier we have solved it for the equations having variables at one side only, like this equation given here. We have shown the different terminology for the algebraic equation like variable, constant, coefficient of x. This equation has only one expression involving variable x on the left hand side, while we have 8 as a constant on the right hand side. हमने already ऐसे questions पहले solve किया हुआ है. Now this time we will solve the equations which have the variable on both sides, like this equation. Variable y is on the both side. We have two expressions on the left hand side and right hand side. Both expressions have the variable y. Let us solve these equations. We have the equation 5y minus 8 by 3 is equal to 4 by 3y plus 3. To solve this algebraic equation, we will group all the variable terms at one place, maybe on the left hand side, and all the constant terms will be grouped together on the right hand side. To do this, we can simply transpose the 4 by 3y terms on the left hand side, and also 8 by 3 can be transposed to the right hand side. But adding these fractions are always difficult and time consuming. So to avoid this from beginning, we will multiply both sides of this equation by some number, so that we can get rid of the fractions. Here, we always try to multiply both sides by a smallest number, so that we can get rid of these fractions. Here, both these fractions have the same denominator, that is 3. So, we will multiply 3 on both sides of these equations. If we have some other denominator, and to convert the fraction into whole number, we will multiply them by their least common multiple, that is LCM. Like on the left side example here, we need to multiply by 6 to convert all the fractions into whole number. While on the right side, the suitable number would be 42. क्योंकि 42 से मल्टीप्लाई करेंगे तो हमारा फ्रैक्शन 9 by 14 and 4 by 21 होल नंबर में कन्वर्ट हो जाएगा. Now, after multiplying by 3 both sides, on left hand side we will get 3 times 5y minus 3 into 8 by 3, and here these 3 gets cancelled, so LHS becomes 3 into 5y, which is 15y minus 8. Similarly, on the right side these 3 also gets cancelled, so we will be having 4y plus 9. Now, to group all the y terms on the LHS and all the constant on the RHS, we can subtract by 4y on both sides, and further adding with 8, we can eliminate the 4y on the right side and 8 on the left side. It is similar to the transposing the terms from left to right and from right to left. Let's do that. After transposing minus 8 to RHS and 4y to LHS, we get 15y minus 4y equal to 9 plus 8, which becomes 11y equals to 17. And by dividing 11 on both sides, we get y equals to 17 by 11. We can also check our solutions by putting the value of 17 by 11 in place of y on the left hand side and right hand side. We should get equal number on both sides. If they are equal, then the solution obtained is correct. Here, LHS is 5y minus 8 by 3. So, putting the value of y, it becomes 5 multiplied by 17 by 11 minus 8 by 3. 5 into 17 becomes 85. And here we can take LCM as 33. So, 85 into 3 minus 11 into 8 divided by 11 into 3. After subtracting this term, we get 167 by 33. This is our LHS. Now, take the RHS. If we put the value of here as 17 by 11 and 4 by 3 into 17 by 11 becomes 68 by 33. Taking the same LCM 33, we will have this fraction, and after adding 68 plus 99, we will get 167 by 33, which is equals to LHS. Hence, LHS equals to RHS, so the solution is correct. Now, let us solve the questions of exercise 2.3, and we have to check our result as well. So, question number 1 of exercise 2.3 is 3x equals to 2x plus 18. As earlier discussed, let us group all the x variable on the left hand side. So, to do this, we will transpose 2x to LHS. We get 3x minus 2x equals to 18. So, x equals to 18. Now, we can also check the solution, and to check it, let us take the LHS 3x and put the value of x here. We will get 3 into 18, which is 54. So, our left side is 54 and right side is 2x plus 18. If we put here the same value of x, that is 18, then we get 2 into 18 plus 18, which is also 54. So, LHS and RHS are equal, hence the result obtained above is correct. Question number 2. 5t minus 3 equals to 3t minus 5. Here also we will take all the variables on the left side and all the constant terms on the right side. To do this, we will transpose 3t to LHS and minus 3 to RHS. We will get 5t minus 3t equals to minus 5 plus 3. So, left side becomes 2t, and as 5 is greater than 3 and the sign of 5 is negative, so minus 5 plus 3 would be negative 2. As coefficient of t is 2, we will divide by 2 both sides. So, we get t equals to minus 1. Now, check the solution. Take first the LHS, which is 5t minus 3. So, putting the value of t here, we get 5 into minus 1 minus 3, which is minus 5 minus 3 becomes minus 8. So, our left hand side is minus 8. And here, right hand side is 3t minus 5. Again, putting the value of t equals to minus 1, we get 3 into minus 1 minus 5, which is also minus 8. So, here we can see that our LHS is equal to RHS. Hence, the result is correct. Our next question is 5x plus 9 equals to 5 plus 3x. On transposing 3x to left hand side and 9 to right hand side, we get 5x minus 3x equals to 5 minus 9, which is equals to 2x equals to minus 4. हम इसे 2 से डिवाइड करेंगे दोनों साइड, so we get x equals to minus 2. Now we can check the solution whether it is correct or not. यहाँ लेफ्ट हैंड साइड 5x plus 9 है, so हम x equals to minus 2 पुट करेंगे. So we get 5 into minus 2 plus 9, which is equals to minus 1. And right hand side है 5 plus 3x. 5 plus 3 into -2, we get 5 minus 6, which is equals to -1. Here, left hand side is equals to right hand side. So, our result is correct. Now comes to question number 4. 4z plus 3 equals to 6 plus 2z. यहाँ 2z को हम लेफ्ट हैंड साइड में ले जाएंगे एंड 3 को राइट हैंड साइड ले जाएंगे. So we get 4z minus 2z equals to 6 minus 3. Here 4z minus 2z becomes 2z and 6 minus 3 becomes 3. On dividing both sides by 2, we get z equals to 3 by 2. अब हम चेक करेंगे हमारा सॉल्यूशन सही है या नहीं. यहाँ लेफ्ट हैंड साइड 4z प्लस 3 है, तो z की वैल्यू हम 3 by 2 पुट करेंगे. 4 into 3 by 2 plus 3, so 6 plus 3 equals to 9. And right hand side में 6 plus 2z है. So 6 plus 2 into 3 by 2, we get 6 plus 3 equals to 9. यहाँ हम देख सकते हैं लेफ्ट हैंड साइड राइट हैंड साइड के इक्वल है. So our result is correct. Question number 5. 2x minus 1 equals to 14 minus x. यहाँ हम वेरिएबल्स को लेफ्ट हैंड साइड ले आएंगे एंड कांस्टेंट को राइट हैंड साइड. सो वी गेट 2x plus x equals to 14 plus 1. Here 2x plus x equals 3x and 14 plus 1 becomes 15. On dividing both sides by 3, we get x equals to 5. Again हम इसका सॉल्यूशन चेक कर सकते हैं whether it is correct or not. Here left hand side is 2x minus 1. यहाँ हम x की वैल्यू 5 पुट करेंगे. So we get 2 into 5 minus 1, which is equals to 10 minus 1. So we get 9. Now our RHS is 14 minus x. Put the value of x is 5. So we get 14 minus 5 becomes 9. यहाँ हमारा LHS RHS के बराबर है. Hence, the result obtained is correct. Thank you for watching the lecture. I hope आपको question number 1 to question number 5 समझ आया होगा. We will solve question number 6 to question number 10 in next lecture. Take care. See you soon.